Started. We're almost 5 minutes past. The first item on the agenda is an update on the progress we've done on cnab-to-oci, and I'll just volunteer Sylvain to give that update, mainly because we've been working on it for the better part of the week. Do you want to say about it, Sylvain?
Oh yeah, so we work together with Radu on implementing the relocation map on cnab-to-oci. So the main idea is, before that, we pushed only a subset of the bundle, which we understood that there were some concern about this. And with the new relocation map work, we thought that now we can use that to store the bundle itself without any modification, and use the relocation map to point to the new images, the new relocated map images. So we did that with Radu, and it's almost a success. It's a success.
Yeah, I think so. So essentially right now, because we're pushing the entire bundle and we're pushing the canonical version of the bundle, we're sure that regardless of how many pushes and pulls you make of that bundle, you get the same content digest of it. And there's also a check in whenever we move it to a different bundle, to a different repo, that the content digest of any of the image hasn't changed. And if any content digest change, then we error out, because you don't get the same content. The relocation map, the idea behind the relocation map is to point to a different repo for an image, but to still get the same content digest of the image itself.
Yeah, and the relocation map is injected at runtime into the invocation image, so the runtime, the invocation image can use it to pull the good images.
Yeah, and essentially this item will enable the last point of the agenda, which is a demo of actually pushing content trust to an ORI server and then moving the bundle around, pulling it again and verifying the same content digest. That's at the end.
So we didn't change anything on the OCI index. We only changed the bundle storing part. So any work based on that, on the OCI index won't change. There's no breaking part on that. If the only thing we removed is the reconstruction of the bundle itself, though we just put it as is. And
yeah, essentially we're still relying on annotations on either an OCI index or a distribution manifest list. And yeah, we're following closely the OCI discussions on adding a config object to an OCI index, so we don't rely on annotations to identify it anymore. Are there any questions on this? We'll open a pull request on cnab-to-oci pretty soon with the changes. Are there any questions related to this so far? Okay.
Sorry, I forgot to ask. So we're not reconstructing the signed bundle, right? We're just using the relocation map to find it in the new registry.
Yeah, the relocation map is only used at runtime to gather the referenced images from your own registry or repo. If any of the images digest don't match the digest in the signed bundle, then runtimes must error out.
Got it. Just wanted to make sure my understanding was right. Thanks.
Yeah. Okay.
Is there a document explaining the design? Sorry to be.
That's the reason for bootstrapping this meeting, to start that document.
Okay, because I still don't think I understand what you said at all.
Do you want to walk walk through it again?
Yeah, maybe that might help.
Okay, so when you do when you try to push a bundle, right now we construct an OCI index, push all of the referenced images that are referenced in the bundle to a repository in the registry, and store the bundle itself as a blob in the repository. And then because the bundle is stored in its entirety and it's stored in canonical form, you can digest it and you can push the content trust to a node server and ensure that whenever you pull it again, you can verify the content digest of it. Does that make sense?
Yeah, that makes sense.
Okay. Was there any other part that didn't make sense from that?
The part about image
Okay, the relocation map, right?
relocation map, yeah.
Okay. So because the bundle JSON right now references images by their location, and location of an image includes the name of the registry, if you want to move the images referenced in a bundle to a different registry or a different repository, and you want to update the bundle, you automatically invalidate the content digest of the bundle because you modified it.
Yeah.
Right? So if you signed the bundle and I want to move the images in a different registry, then I can't rely on on the signature anymore. So assuming that we move the images to a different registry, and the registry generates the same digest for the images, we generate at runtime a relocation map that essentially points out to the new location of the images in the new registry. And we ensure that the content digest of the images is the same as the ones referenced in
How do you, from what information do you generate this map?
The map is generated based on the existing images in the bundle JSON file and the new images pushed in your registry.
Yeah, from the OCI index.
But what do you do with this map? You push it to the registry, the new registry?
No, it's used at runtime. So when you
Okay, but how do you, what's the workflow for the user at runtime? How do I say I move my images? How does it know what map to generate?
Yeah, so whenever you
pull the bundle, it generates the relocation map from the bundle and the OCI index it just pulled. And
I would just based on the name of the registry you pulled from.
Yeah. So the result of pulling is a bundle and a relocation map.
Okay. So it needs to just know the name of the registry you're pulling from.
It's the only way to ensure that you can move a bundle to a different registry and not invalidate the signature of the initial signer of the bundle, because image names are part of the bundle.
Yeah.
Could I follow up to Justin's questions?
Sure.
So this raises a few interesting questions, right? I think I can see some of Justin's concerns, that if I have the right word. One is that, what is our common use case? So it looks like our common use case is you're probably going to trust the bundle to tell you where to fetch things, right? You already trust the hashes in it, the digest in it. One way to solve this problem is to say the bundle doesn't tell me where to download from necessarily. It just gives me the hashes, and then I can download from wherever they like as long as the hashes match.
You can't, though. That's the problem about the registry auth model, is you have to have an image name in order to pull a hash.
I see.
Now, I'm not strictly sure if that's really necessary. I mean, it's complicated, but there's the security model says you have to have basically you either have to prove you have a hash or have authorization for a known repo with it before you can pull it. You can't just make up a SHA-256 hash and then get its contents miraculously appear. Even though arguably that would also be a reasonable security model.
Right. But adding the image name doesn't give you any additional security, right? It just...
No, not really. It just tells it where to check authorization against.
Right. Right.
Therefore, if in effect it proves that someone with that someone with the same permissions as you was able to push it, and therefore it's okay for you to pull it.
So you're assuming authentication on top of that to, let's say, a private repository. Do I understand you correctly?
Yeah, strictly it applies to public repos too, but it's effectively for public repos, it doesn't really have much effect.
Yeah, not really. Okay, I see. I don't see too much of a major security concern here. As long as the bundle runtime doesn't ignore the hash, relocating the image, domain, the server really shouldn't be a big problem.
And then my follow-up question on that is, I can relocate the image to a new registry and not invalidate the digest of the image, the content digest. Can I do the same with the trust data for a specific image?
Not right now, but that is the plan. I mean, in principle, yes. In principle, it just signs hashes and sizes, so it's fine.
Okay. Okay, thanks. So is this a reasonable approach? The one that we've been describing?
Yeah, I think so, but it's just, I mean, it feels weird, but I think it's reasonable.
Yeah, as long as you don't trust, presumably the relocation map is not signed, and as long as you don't download it somewhere random off the internet and trust it.
We generate it at runtime whenever you try to use a bundle.
It doesn't technically matter. I mean, it's effectively just telling you where to auth against.
Right.
And authing against the wrong place doesn't do bad things. It'll just either succeed or fail.
Right. And you're not silently ignoring mismatching digest either. So
no, so you get the same, as long as the content hashes will be the same.
Right.
Just a rerouting to where you get them from. I mean, I kind of imagine that somehow we can, but I haven't worked out that we can invent some system where we can just have URLs for content hashes and we indirect on how to actually authorize them. But
oh, Justin, I think maybe it's not clear from the discussion here is that the use case for relocation is that they want to use, correct me if I'm misunderstanding, that they want to turn a thin bundle into a thick bundle. Well, no, even for a thin bundle, you want to redirect everything to an internal registry. You want to tell the bundle runtime, don't go anywhere outside at all. Just use my private registry. That's I think is the most common use case for this.
Yeah, I mean, there are several use cases, but yeah, I think that yeah, I think it's probably okay. I mean, yeah, I wonder if we can make a different, more generic mechanism later, but yeah.
Okay, thanks. We should probably start writing some of this and passing around for people to validate. The next thing we have on the agenda is whether or not we should also push all of the images on duffle push. That's more or less related to how cnab-to-oci actually implements moving the images when we push a bundle. Sylvan, do you want to talk about how cnab-to-oci does that right now?
Yeah. So the first thing we do is pushing all the images, pushing or mounting all the images into the same repository. So we can refer from the OCI index, and it has also some advantage, like some benefits, like we have a guarantee that if you can pull the OCI index, you can pull all these images, all the invocation images, all the component images. Whereas it also prevents the garbage collection from removing your images without you noticing it. So it has lots of benefits. That's why we made that. Yeah.
Okay, but essentially the part that is important for tooling is cnab-to-oci right now expects all of the images referenced in a bundle to be already pushed to their respective repository or registry. The question is, how should tooling handle this? Should they push the referenced images before, or should the library that pushes the bundle do that as well? Do people have strong opinions on that?
I don't have strong opinion on that, but why we didn't do it in cnab-to-oci is we wanted to avoid the big dependency on Docker itself. That's why we used only containerd. But if that's okay for everyone, we can use a Docker client to push it from cnab-to-oci.
Yeah, let's wait for people to actually shout about it. Trishang, do you want to walk us through the draft of the security spec that you mentioned last week?
Yeah, sure. Would love to. I mean, yeah. It's about time that we start this, and I'm glad you guys organized the meeting. Thank you. Let me share my screen. Should have joined the Zoom meeting earlier from here. So far, it's just been me writing everything. So pretty sure I didn't get everything, or there'll be lots of changes. But it's the whole point of this. Okay, let me continue. Share my screen. Okay, you guys can see my screen, right? Oops. Okay, so this is the spec that I know doesn't fully make sense yet, but I want to try to quickly walk through. Okay, so the idea is basically we want to use two technologies called duffle and Toto, right? And what they roughly do, I'm just going to give a high-level overview. I don't think we should drown at details at this point yet, but I want to talk about part of the rationale. Let me give a quick overview of what Duff does and what Intoto does, so it's kind of clear. So just to give a rough idea, and I'm going to use it. I'm going to use the Datadog agent integrations, which uses both, to give you a rough overview of what security properties it provides, and then we can talk about how that applies to CNAP. Does it make sense to everyone? Okay. So at Datadog we have we monitor the infrastructure and your logs and your applications for you. And we do this through the agent, through a software called an agent that you install on your host, on your containers. And they come with plugins basically that we call integrations, right? That let you monitor new things. And we needed to be able to build them separately on demand from the agent. And the way people typically do this is to use CI/CD, which is great. You don't want to give developers your signing keys. So it's better security in that sense. It's also faster building and deployment. So there's a lot to be said about it. But what can go wrong in this model, right? So when no one has compromised your infrastructure, things are good. But things start going horrendously wrong when your developer is compromised, for example, one of your developers, or your version control system, let's say it's GitHub, or your private infrastructure on the cloud, your CI/CD, your key service and so on, your image registry. You get the idea. So CI/CD is great. The pros are, faster deployments and so on. There's no going back really. But the problem is that there's no property that we call compromise resilience. The moment anything between your developers and your users gets attacked, it's basically game over. And the key idea is we don't want it to be a game over. We want to raise the bar for attackers. And the way we do this is using this thing called, I'm not going to walk through the horror stories. It's important to know that TLS alone doesn't protect you. Just to quickly knock it out of the way, why not just use SSL? It's better than nothing. For sure, it protects you from man-in-the-middle attackers, but it doesn't protect you when the infrastructure itself has been compromised, because now your attackers are basically signing things for you. GPG, nobody really uses this in practice because key distribution is a hard problem here. GPG doesn't really solve it in a good way, especially key revocation. Yeah, let's keep it short and simple. So we cannot prevent an attack. We cannot prevent a compromise, a key compromise, but we want to make it, we want to limit the impact of a key compromise as much as possible, right? So we have to compromise multiple keys for it to be completely game over. And so this is where duffle in toto comes in, right? So what is stuff? What is in toto? I'm going to try to explain using a... So we want to achieve compromise resilience, this property that you can detect an attack, not prevent it, but you can detect it. And we want to use this using an idea called tamper-evident CI/CD. So you want to specify rules for your CI/CD, right? So developers write source code. Your CI/CD is basically, you can think of it as a function sitting on the sky, consisting of multiple steps. We can still think of it as a giant function that takes your source code, your developer-signed source code, and packages it for you. Could be tarballs, could be binaries. And you want to be able to detect deviations from this pipeline. If it's not your authentic pipeline doing this for you, you would be able to detect the deviations in the behavior, right? And so in toto, you can think of it as protecting your software from the moment it was created by one of the developers to the moment that it's packaged on the CI/CD, right, to the repository. Does it make sense so far? And Tuff is the thing that protects your software packages, container images in this case, from the moment that's on the repository, on the image registry. The repository is just a server containing metadata and your images, for example, in this case, packages, anything you like, any software artifacts you like, to your end users. So each of them solve different problems, right? And when you put them together, you basically get end-to-end security anywhere between your developers and your end users. If you see deviations from what you prescribe your pipeline to do, you'll be able to detect it, and people wouldn't install malicious images or bundles. Does this roughly make sense? Great. So in toto is the part that protects you from developers to CI/CD, right? And how does it work? The way it roughly works is that you prescribe your pipeline as a series of steps. So for example, there's a write step where one of your developers, say Alice, is going to write source code, right? So this is one step. And then there's a packaging step that takes the output of the write step, right? So you can think of each step as producing input and output. So in this case, developers don't take any input, but they produce all the output, which is source code. And then you have an intermediary step in between called package, which is what your CI/CD takes. So it should, in good times, take source code written by developers. There should be no attacks in between. And if there is, you can check it. And then it packages it for your users. So it could be a simple case of just zipping all the source code, Python source code, let's say, in a zip file. Or it could be compiling that source code for you. For the moment, we'll ignore binaries for the moment, although there are techniques to deal with that. But if someone really presses me later, I'll answer the question for you. And then at the end, what will happen is, so basically each step produces signed attestation. It's saying, so developers who sign an attestation saying, I have no input, but I have made all this output. And then the packaging step, which is your CI/CD, would say, I got this input from GitHub. It should match what your developer signed. And then I made this resulting tarball as a result. And then end users, this is transparent for all of them, they would put together all of the signed attestation together, these links, and check that the links, that the attestation match rules that you prescribe for your pipeline. Right? So for example, the rule of this pipeline is Alice, for example, is allowed to produce source code. The packaging step must use the same source code that Alice signed. So the hashes change, something is wrong, don't trust it. So if the hashes change, if the hashes match, then you go on and check, well, what did the package step output? It outputted this tarball. And I'm going to check that the hash match what it outputted. And I can do interesting things like I can unzip the tarball to make sure that the source code inside it is exactly what Alice signed. Right? So I get really nice end-to-end security like this. So what the update framework does is it secures, you can think of it as the bootstrapping of trust layer for all of this in-toto links. So the problem that in-toto doesn't solve is that this pipeline itself is metadata, and that's called the root layout in the simplest case. And that metadata itself needs to be signed. And how do you know, how do you get keys for the whole system? There can be a whole bunch of steps here. What happens if you change keys? And in-toto doesn't necessarily solve that for you. And we use stuff as a bootstrapping layer. And Node3 is already using this for container images. I'll talk about what that means. So repository, just to get it out of the way, is just a server that contains your packages. In this case, you can think of the container images and metadata, which is data about those packages. So tough metadata roughly looks like this gobbledygook JSON that you see here. There's a whole bunch of signatures by all these key IDs, tells you what methods and so on, and there's a bunch of files, and these are their hashes and so on. The way Tough has designed this, remember I talked about compromise, resilient, no one key failure. So a common question is, why not just use GPG? It's the simplest thing to do, right? There's one key. Well, that's the problem with GPG. There's one key, and because we live in a DevOps kind of world, that signing key is probably going to be in your infrastructure somewhere, not in cold storage in a nuclear proof bunker in Switzerland, for example. So maybe sitting there in infrastructure, one signing key, and the moment it's compromised, that's it, it's game over. So the way Tough is fundamentally designed is that we have at least 4 different roles. These are just, a role could be either a human being, like a developer or an administrator, or a machine, CI/CD step doing this for you. And different roles sign different types of metadata, so that if you get to one of them, it's not necessarily game over. So like grandma would say, don't put all your eggs in one basket. We also have this idea that's become very popular these days, especially in cryptocurrencies, is the idea of threshold signatures, multi-signatures. Grandma would have said, if you want to launch a nuclear missile, make sure you use at least 2 different keys, right? They must come together. And so in this case, we apply the same idea to signing container images. We also built in key distribution and revocation for you. This is something that GPG fails to do. So for example, worst case, one of the developers does get his key compromised. It's okay. You can use something that we call the root key, which is the root of trust for the whole system, transparently distributed for your users without them having to do any manual stuff. And the other thing that we have, another design principle, is that you don't want to keep all of your signing keys online on your infrastructure. It's like keeping your signing keys on keeping the key to your house under the carpet, right? It's a bad idea. You don't want to. The keys to the kingdom should be protected in cold storage, for example. Another thing that we do that a lot of people don't do is to have something that a lot of people call crypto agility. It's the idea of hedging your bets. You don't want to place all your bets on one suite of signing or hashing algorithm. And Tuff does that naturally for you. You can use SHA-2, SHA-512, SHA-3, anything you like. The more you have, the better. It's unlikely that attackers can break them all. And so, yeah, Datadog, we basically combined the two, Tuff and in-toto, and we believe that this is basically one of the world's, if not the first, one of the world's first integrations of both. And people are actually using this in practice. And if attackers compromise our infrastructure anywhere in between, we would know. We would see this. And I don't want to go through all of the details, but if you really press me later, I can send you links and I can talk about it. But that's basically what Tuff and in-toto does. Does this roughly make sense? Let me just throw this picture up here. And if anyone has questions, please ask me right now. Okay, so the way Tuff is being deployed by Docker right now for Docker Hub is a version of Tuff called Notary. And each, Justin, please correct me if I get details wrong here, but each image repository is basically its own Tuff repository. So it has its own different set of metadata that's completely different from other images.
Yeah, that's right, yeah.
And so that's how container images are being secured by Docker today, right? And so we're going to use some of the same techniques for CNAB bundles here. We can and should reuse. Oh, I'm showing the wrong standard. So basically the standard talks about signing two different things, right? One is the images themselves, and Notary gives you this protection already. You can you can reuse existing signatures that, for example, Docker Hub or even Quay gives you. And the other thing is that you want to sign bundles, right? And these are two different things. Conceptually different. It sounds complicated, it sounds unnecessary, but here's the reason. The person making the bundle could be, say, Datadog, for example, right? And we could be using completely public images whose signatures we don't control. So they're a completely different set of keys. So signing our bundle is conceptually, and in this case, even physically different from signatures on those images, right? Does this roughly make sense? And so I want to talk about the levels of security that we can introduce here. We cannot, it's really difficult to install all of the security. It's like, oh my God, let's just roll out Tuff and in-toto and sign our bundles and images all at once. It's too much work. We found out even in practice here, deploying Tuff and in-toto. So here's what I prescribe. I have this idea of different levels of security. So I guess level 0 is no signing of bundles or images, and that's okay, right? It's not recommended necessarily, but it's a starting approach. It's okay. But what we want to start with ideally is level 1, where we sign our bundles using Tuff. In this case, Notary, for example, implementation. But we don't sign the images themselves necessarily. There's still a lot of unsigned images out there. That doesn't mean you cannot use a bundle that refers to unsigned images. So this is the easiest level of security to achieve. The level 2 security is both bundles and images are signed using Tuff. And that gives you better security because now when you build the bundle, the downside with level 1 is your bundle is trustworthy, but when your bundle goes out to fetch the images, it needs to get this digest from somewhere, right? How does it know that the digest is trustworthy? In good times, the digests are probably good, but if it reaches to a compromised registry and blindly trusts the hash, well, even if you sign your bundle, those images are not trustworthy in the first place.
Yeah, but the hashes are in the bundle,
Yes, you're right. What I'm trying to say is, if I go out and if I'm the bundle runtime and I pulled an unsigned image, how do I know that that hash corresponds to an authentic image? Does that make sense? Let's say they didn't sign it using notary.
Because you have the hash for it in the bundle.
Yeah, I understand. But if someone has compromised the image registry and replaced the image with something completely malicious, it would have a hash, but that doesn't mean that the image is trustworthy. And so what level 2 would give you is, if you have signed your images using notary, then I know that those images are trustworthy.
I don't know that I agree that that's the right model. I think constructing a bundle is part of the pre-registry phase and should be an in-toto. Should be something that in-toto handles, because it's part of constructing the final artifact that you're going to pull.
Yeah, this is what I'm getting into. So in the first level, when you sign your bundles using Duff, what are the security guarantees that you get? You get guarantees that no one has tampered with your bundle, which is good, but there's no guarantee that the images in the first place are trustworthy. Level 2 at least tells you that the images that the bundle runtime pulled is trustworthy in the sense that presumably developers signed for it. It's not just, so for example, level 1 is the equivalent of me using curl to fetch a script from, Homebrew right now, which is what, protected over TLS, right? That doesn't mean that no one's compromised the TLS server and replaced the script. So that's not good enough. And so if, let's say, Homebrew used Stuffed and signed their script that way, I have more guarantees that it came from human. You are right that level 3 and level 4 would give you more security. Here's the problem that Duff alone doesn't solve. Duff gives you a bootstrap for the whole system, but even if you sign for your images using Duff, if your images are basically being built by CI/CD, there's no guarantee that a CI/CD hasn't produced a malicious container image, for example. Right? And that's what in-toto gives you. It gives you deeper protection end-to-end. And you would use Stuff to download all of the in-toto metadata. Does this roughly make sense? And so level 3 is you start introducing in-toto, and you use Stuff and in-toto for the images, but not for bundles. And level 4 is you use Stuff and in-toto for everything, for both bundles and images.
And one of the things we would get from using in-toto in that pipeline is for the cases where the binary that gets injected into the image also needs to have some cryptographic verification that it was produced correctly, right?
Exactly. You hit the nail on the head. Right. So in level 1, you don't really get any assurance about the images, right? Because you don't really know whether the hash for the image is trustworthy in the first place, because you could have downloaded it over HTTP, HTTPS, doesn't matter. The point is there's no authenticity at all. Radu, I'm getting there. I'm getting about how we distributed in-toto rules and pipeline. The short answer is use Stuff. Because there's so many keys, for the, okay, so in-toto has got all the steps, right? Steps A, B, C. Can everyone see me, by the way? Let me use a picture here. So for example, in the agent integration, so for example, here's our pipeline. This is one root layout file, and there's 3 steps in it, plus an inspection at the end that tells you how to check all the steps in this. So in our case, we have Python source code that developers sign with YubiKeys, and we have CI/CD in between that takes that source code, basically zips it into a file. It's just a tarball. There's no compilation here. This compilation, the story is more complicated, right? Because how do you know? Because if it's a simple tarball, you can always unzip it at the end, which is what our in-toto inspection does transparently in the end for users. It downloads the zip file, right? And checks that the source code inside, the hashes of it matches what developer signed, right? With a binary, you can see it starts getting complicated. How do I know that the compiler is trustworthy? And then we can use reproducible builds for this, which is probably what we will eventually need for containers. But if we complicate everything and introduce everything all at once, then we'll never get anything done. So we'll have to introduce security layer by layer. So anyway, this is our in-toto pipeline. It's got 3 links in it, right? 3 different pieces, 3 different steps, and 1 root layout file. Now, how do you get the signatures, the keys for this root layout file? And that's what we do with Duff, basically. And so the way it works, there's a lot of details here I don't want to get into, but there's, I looked at one point to inject into the custom field in the, sorry, I didn't see the whole.
Oh, sorry, I was trying to answer Radu's earlier question, so keep going. Sorry for distracting you.
Sure. So the way we do it now is that your end users, so in this case, our agent, people use the agent, right? If we had to ship in, and there's so many keys in the system, there's the in-toto root layout keys, and then every step has got the key for the links and everything. How do you get the root layout keys? And that needs to be offline. It needs to be in cold storage, basically. Otherwise, it's not really trustworthy. Otherwise, the machine can change the root layout all the time. So what we do is we use stuff to bootstrap everything. So if you just ship 1 metadata file to your user, to our agents in this case, you can change the keys for the rest of the system and the agent would still work. It wouldn't care. And we've actually done this multiple times. It's really nice. So we use stuff, cold storage keys, to distribute the root layout and the public keys you need to verify the root layout, you see? And then your container images can be signed by a machine. We don't really care because we have the rules now. You can think of it as offline rules. So if this guy, and I painted it in red, everything using online keys, or keys under the carpet as it were, is painted in red to sort of highlight the danger. The green is to say it's securely distributed. Even if I break into our infrastructure and try to tamper with this, the signatures wouldn't match. I would be caught. So I basically made immutable the in-toto root layout, the pipeline, basically. Your pipeline is immutable. And the keys required to verify the rules in this pipeline is also immutable. If I wanted to change it, I can. But in the meantime, it is immutable. And all I need is this root tough metadata file that distributes everything. The other reason why you want to use stuff also is to protect you from things like consistency attack. There's a lot of files floating about here. Every container image, every tag could be associated with a completely different set of links. So how do you know which image, which links correspond to which image? Does this roughly make sense? I'm sorry, maybe I missed someone else's question too. I can't remember there was another question. But this is roughly, I hope answers the question of how do you distribute the in-toto public keys for the bootstrapping in-toto's trust in the first place. And use stuff basically as the secure, you can think of it as the secure transport layer. It's more secure than TLS because with TLS, if you break into it, I can man the middle it and distribute you any in-toto public key that I like. You can say, why not just use GPG? You could, but the problem with GPG is key distribution. It's just not, it's not very good. With Duff, on the other hand, is transparent, and we've done this before. Like, for example, I have different versions of root now, version 5, I think, and every time I switch the root, even though every key in the rest of the system is different, our end users can't tell the difference at all. From their point of view, nothing has changed. And so what I'm proposing in our CNAB model is that roughly, we start with the simplest thing to do, which is to, what's my thing not moving? Ah, there we go. So there's this idea of, and I'm overloading terms here, which I'm not happy about. This is what I want to talk about with people, is what I mean by repository here. So an image repository is not the same as an image registry. You can think of an image registry, so let's stick with containers. I know that CNAB can do arbitrary things like virtual machines and anything else, but let's just pretend that we're just using container images right now. Oh, 10 minutes. Sorry, I didn't want to take up too much time. Sorry, there's only 10 minutes left. Should we, does anyone think I should answer other questions in the meantime?
The only other thing that I have is a demo for the step 1 of your security model, which is pushing the metadata of a cnab bundle JSON file to TUF and then pulling back and then checking against the local file and the registry and the TUF metadata.
Right, and I don't want to take away from that. I also don't want to leave people hanging, but there's too many details, unfortunately, and I'm happy to follow up over CNAB. What do people want to do? So
this is an open PR against CNAB Spec right now, right?
Yes.
Yeah. Okay. So I will go read this because I like the direction we're going. I want to think through those 4 layers pretty carefully.
Sounds good.
Justin, did you have other stuff you wanted? I know your time is probably the hardest to get a hold of. Do you have other stuff you want to ask about right now? Should we do?
Not right now. What's the best way to comment on this document, though? Just slightly inconvenient for commenting.
Yeah, this is true. A PR, well, I mean, I haven't made a PR yet, but once I make the PR, you should be able to comment it from GitHub. Is that good, or should we do something better?
Yeah, because I'm at the point where I've seen enough of this document to make me think PR and commenting on the PR is a good next step for this, because I like the overall approach. It's more a matter of thinking through. You presented a lot of information, and it's going to take me a little while to mentally.
Yeah.
I'm really Justin commenting on a PR.
Okay, sounds good. Yeah, I'm really sorry that there's too much information here, but I've tried my best. And again, yeah, I'm happy to answer questions offline. Radu, please go ahead.
Let me know when you can see my screen. Okay, so essentially this is implementing the second part that Trushank described, which is when you have a bundle, you want to push the metadata to TUF, in this case, Notary. So specifically, you think of this command, the sign command, in the same way as the docker trust sign command, which essentially takes the metadata for an image, pushes it to Notary, and then pushes the artifact, which is the container image, to its the specific registry. So in this case, this is going to take the metadata for the bundle JSON file, initialize a new trusted collection into a remote Notary server, and get the digest of that file, then push the bundle to an OCI registry using cnab-to-oci. And then the second part of this is that you can do a verify and ensure that that first of all the metadata that you pushed to Notary is the same as with the metadata that you compute from the bundle that you pull. So we can see that the computed SHA that was computed locally of the file that was just pulled is the same as the one that was pulled from Notary. And we can also verify against a third one, which is a local file, which is the same bundle that we pushed initially. And we can see they're the same. And if somehow we modify the file and pass another one, we can ensure that the file has been modified between the operations. This works also if we push the bundle to a new, repository as well. And we see that we generate the same content digest in any case. This is authenticated. Now a third-party user can try to push the bundle, and it fetches the metadata from Notary, and the same thing happens all over again. Are there any questions so far? If we agree on that the part Tushank described about tough is the thing we want to go forward with, this can be added to duffle, and essentially it's the verifying that the bundle metadata is the same. What this doesn't implement is pushing metadata for images and verifying the metadata of the images.
No, I don't think I have exact. I mean, it looks great. That demo alone is exciting. This is a great start. And so far right now, this is signing the bundle, right? Not the images.
Yeah, this is taking the content digest of the bundle JSON, and it's using that to initialize the trusted collection and push it to Notary. Yes.
So it's approximately level 1 of your 4 levels.
Yeah, exactly. I was going to say that this is fantastic. We already have level 1 security, so this is fantastic. I'm glad that our thinking is converging. Yeah, the only, so I would say one thing that my standard is proposing right now, and I'm not saying that we should be married to the idea, is that I'm using something in Tough called delegations. The way that Docker Hub does it right now is that there's a different set of root keys basically for every image you're trying to pull. And I'm trying to simplify that and say that we can use one set of root keys and use something called delegations to distribute the keys for each image. You see, even though they're different, you can still have one root. And as long as you trust that root, you get the keys for the rest for free. And so I think that would simplify deployment in some cases, but it may not be strictly backwards compatible with Notary right now. And that's something that we should argue about, and we should think about how to make all of this work. I just wanted to say this so that if you read the spec, you're not confused. So for example, Justin looks at the text like goes like, wait a minute, this wouldn't work right now. So.
And before we go, I have one more question, which is related to, so if we sign the bundle and then decide to move it to a different registry, the content digest of the bundle continues to be valid, and we can reuse the initial signature. That's not the same that we said earlier with the images referenced there. Is it valid? Is it a valid operation to, when I move the bundle to a different registry, to re-sign the images and push the trust data to a new Notary server, and then use that together with the relocation map, so that I can still continue to have signed images? Does that make sense at all?
Yeah, Justin, would you like to answer this?
No, not in 1 minute. Yeah, I mean the whole design for moving signatures needs fixing.
Yeah, maybe it wouldn't work right now, but in principle, I don't.
In principle, there's no problem.
Yeah, it's not impossible, exactly. And yeah, it's not going to work out of the box right now, but in principle, there's nothing impossible about this. We just need to write the code for it, basically.
So to try and wrap things up then, so this, the PR you proposed today is light years ahead of the current state of the proposal, which was basically my napkin drawing turned into a one-page document. So I would love to try and move this forward so that at least we've got something substantial to be working on. Even if we need to clarify things and discover and remove warts and things like that, this puts us so far ahead of where we are now. I would be thrilled with turning this into basically the working draft instead of the thing that's there now. So can we revisit this on next Wednesday around the same time slot, which is our official CNAB meeting, and see if we can start getting this in as the working draft of what we want to work on? Is that okay with people? If we can't make a decision today because we don't have the full quorum, but if we add that onto the agenda officially for next week, I think we can start that process officially. Does that sound good for people? Okay. Yeah, thank you everybody. I know this is really tough stuff to work through in one, but it seems to be easier to get one deep overview so that everybody kind of understands how the pieces fit together, and then we can make some progress a little more rapidly than we have. It would be great to get some of the other people that have been deeply interested in security involved in this too, like Chris. This is Chris G. But this is a fabulous step forward for us from where we were a week ago. All right. Anything else we need to cover? We're at the top of the hour now. All right. Thanks again.
Great. Thank you. Thank you, everyone. See you
See you guys next week.